I am Andrea Knight Blackwood, and I will be leading you through today's chemistry lesson. Let's get into it. So, our objectives. So at the end of the lesson, you should be able to define the term standard solution, and you should be able to use volumetric analysis to calculate the number of moles, the mole ratio in which the reactants combine, and the concentration and the mass concentration of reactants. So remember last week we looked at mole concept, we looked at how to calculate mass concentration and mole concentration. So today we'll be looking at volumetric analysis and how to incorporate the mole concept in volumetric analysis. Okay? So we're looking at a solution. So a solution is made from a solute and a solvent, pretty much like our sugar solution. Water is our solvent and sugar is our solute. So when we add our sugar to our water, we create our solution. All right. So last week we looked at concentration. So we looked at concentrated solutions and we looked at dilute solution. So picture coffee. We can have strong coffee and we can have weak coffee. So let's just substitute the words weak and strong. So if we say our coffee is strong, then we would be saying that it is concentrated. If we say that our coffee is weak, then it would be a diluted solution. All right? So since we understand that, let's move on. Remember that 1 dm cube is equivalent to 1,000 cm cube, right? All right. So let's talk about our units again. So our units for mass concentration is gram per dm cube, which is written with our G/dm3. And our moles per dm cube is written as mol/dm3. Now, here is a solution. It has a mass of 58.5 grams, and our solution, 1 dm cube. Right? So we'll be talking about the meniscus and how to read our solution using the bottom of the meniscus. All right. So again, we know that our concentration can be written as mass concentration or mole concentration. Mass is grams, so it will be gram per dm cube, and mole, our molar solution will be mole per dm cube. Okay, remember that the amount of mass that is dissolved in our volume gives us concentration. So we can use concentration, we can use gram per dm cube to give us our concentration, or we can use our moles to give us concentration, depending on what the question is asking. So the question can ask you to find molarity. Remember, we can substitute the word molarity for when we're finding moles per dm cube, right? All right. So we have something exciting planned for you today. So before we get into the little experiment, let's do one calculation. So the question says a solution of sodium chloride is made by dissolving 11.7 grams of sodium chloride in 500 cm cube of solution. Now remember that sodium chloride is our table salt, right? So it's just a fancy name for it. Sodium chloride is a scientific name, but it's really table salt that you use in the kitchen. So again, a solution of sodium chloride is made by dissolving 11.7 grams of sodium chloride in 500 cm cube of solution. Find the concentration of the solution in grams per dm cube, and also find it in mole per dm cube. What is the first thing that we do? The first thing that we do, we notice that we have volume and we have mass. The question is asking us for gram per dm cube. Now we have cm cube. How do we convert from cm cube to dm cube? That's right. We divide by 1,000. So our 500, which is our volume that we got, we divide it by 1,000, and there we have 0.5 dm cube. So the next thing we do is to find the concentration. Since we're doing grams per dm cube first, we would divide the grams by the volume, right? So the concentration Our units are gram per dm cube, so we divide 11.7 by the dm cube. What is our dm cube? 0.5. Okay? So after dividing 11.7 by 0.5 dm cube, we should get 23.4 grams per dm cube. All right? Now, we need to calculate, we're going to do B. B is asking us for moles per dm cube. Now, when B is asking us for mole per dm cube, we notice that we only have grams. Now, if we have grams, we have the molar mass of sodium chloride. So how do we calculate molar mass again? That's right. We add the mass number of sodium, which is 23, plus chlorine, which is 35.5. So 35.5 plus 23 will give us our 58 grams. All right, so this unit is gram per mole, and 11.7 is grams. So when we divide what we got in the question by the molar mass, we will get 0.2 moles. And if we have 0.2 moles, how do we get mole per dm cube? How do we calculate molarity? Now, the question says they want mole per dm cube. So this slash right here means that we divide by the volume. So if we have 0.2 moles and we're to divide by the volume, what is the volume? 0.5 dm cube. The question asks us for dm cube, and we have it right here, and we calculate moles. So all that is left for us to do is just to divide 0.2 by 0.5 to get our molarity. So our answer is 0.4 moles per dm cube. Lovely. Now, we're going to look at volumetric analysis. What is volumetric analysis? Well, volumetric analysis is a method of finding out the quantity of a substance present in a solution. Basically, we don't know what mass is in our solution, so we can use volumetric analysis to find out molarity or to find the mass. Now, it usually involves titrating. So it can be called volumetric analysis or titration. So what you will be doing in school is your titration. So our titration involves a standard. So when we use our standard now, what is a standard? We discussed this last week. What is a standard? Yes, a standard is a solution that we know the concentration of accurately. Okay, so we can use a standard to calculate our unknown. So in our reaction, we use a standard to do our titration with the unknown. All right? So here, we're going to learn how to use the utensils, the equipment. All right? So we're going to learn the first thing. So it is a bit technical. So practice makes perfect. So here we have a student that will be showing us how to do it. Ruthann. So Ruthann will be showing us how to use the pipettes to pipette our solution. So here we have our standard sodium hydroxide, and it's very important for us to label our flask. So here we have a 1 molar solution of sodium hydroxide, and she will be pouring some of this into a beaker. Okay, so here she's pouring out some of the sodium hydroxide solution, after which she will be using the pipettes. So we have different size pipettes. It depends on what the question is asking you for. Here we have 2 pipettes. We have a 20 ml pipette. Here, this one is a 20 ml pipette, and it's very big. It's larger than the 10 ml one. We have 50, we have 15, and we have 25. We have different ones. But here today, she'll be using the 10 ml pipette to pipette 10 ml of the sodium hydroxide into the conical flask. So here she's adding the pipette filler to the top. And she will be pipetting only 10 mils of the solution. So the pipette is an instrument that we can use to get a precise measurement. So what you should be looking for when using the pipette is the mark that tells you when you have collected 10 mils. So here she's pulling up the solution. So she's watching the solution to ensure that the solution passes the mark just a little bit for her to remove the bulb from the pipette. All right, so this is the point where she's going to release it using her index finger down to the mark. Go ahead, Ruthann. Oops, Ruthann passed the mark. So if it's below the mark, then it will be less than 10 mils, and that's what we're trying to get today. So you shall get it right. Right, Ruthann? Okay. So while she's trying to get it right, we'll talk about the steps. So we're trying to pipette exactly 10 mils of this solution. So before, the solution should be washed with tap water first. Then you can wash it with distilled water. Before using some of the sodium hydroxide solution, we should pre-rinse the pipette with our solution that we'll be using. In this case, it was pre-rinsed before with our sodium hydroxide, so we just continued to pipette up the solution. All right, so we are using a pipette filler. Notice that she's wearing her gears, her safety goggles, and her gloves, and also her lab coats. All right, so this is what is happening in the diagram. Here we have the solution being pulled up using the orange bulb, which is called a pipette filler. Now, you will have to practice this when you're in the lab. So let's continue. We have the burette. Now, a burette is used in titration. Now, the burette is a bigger equipment, bigger than the pipettes, and it is read to 1 decimal place. Now, what is inside the burette is called the titrant. We need to remember these key terms. So we're doing a titration, and what is in our burette is called a titrant with a T at the end. All right? Now, the burette looks like this, much bigger than the pipette. Pipette is small, the burette is bigger, and it is read at eye level to 1 decimal place. Now, when we are using our burette, we normally use a retort stand or a clamp stand to clamp the burette there, and so that it is held vertically. It stands up because the burette will not stand on its own, so we use this clamp stand to hold it upright. And again, it is read at eye level. You don't stand above it you carry you're to adjust it at eye level. Oh, look, Ruthann did it. So she now has 10 mils in the pipette after several tries. So what we are going to do, Ruthann, you're to put it in the conical flask. Well done. Good job. After several tries, she got it right. Lovely. So here she's allowing it to run out into the conical flask. And guess what? She has to do it again. So while she's doing it, let's continue. So the burette must be read at eye level, right? We don't stand above to read the burette. We stand directly at eye level. So sometimes we have to bend down. We have to bend down to read it at eye level, but we don't go below the meniscus again. The meniscus is where we would read it. All right. Now, safety tips when we're doing our experiments. So when we are filling or reading the burette, it should be lowered to a suitable height. Do not attempt to read it by climbing on a stool. Students tend to climb on a stool because it's so tall, but we need to adjust the clamp stand so that we can read it at eye level. The next thing is to make sure that the tip of the burette is always kept below the surface of the liquid when it is being filled. Otherwise, air bubble will get into the pipette. All right, after filling the burette, the small funnel should be removed from the top of the burette. We don't titrate with our funnel in the top of the burette. And the titration flask should be placed on a white tile. So after adding our sodium hydroxide to the conical flask, before we start our titration, we need to have a white paper or white tile to do our titration. Why do we need this? To see the color change. Sometimes we're using some indicators that will be pale or light in color. So we would need a white tile to show immediate color change when it is made. All right. So sometimes we need to use a wash bottle also to wash down the sides of the conical flask. Okay, she did it once more, and so now we have 20 mils of our sodium hydroxide solution. So when we're going to titrate, if we're going to use HCl, HCl will be a colorless solution as well as sodium hydroxide. So when we have titrated and we have arrived at our endpoint, how will we know that all the moles have reacted? We need to use an indicator. An indicator will tell us about our endpoint. So here we're using today phenolphthalein. So she will be adding our phenolphthalein indicator to our base. So what is the color change when we add our indicator to our sodium hydroxide? That's right, it will turn the solution pink. Swirl the conical flask there. Lovely. So that's a light pink. All right? So that's what we're starting with. That's what we're starting with. We're starting with a light pink solution. So when we have arrived at our endpoints with the HCl, it will go from pink to colorless. Lovely. That's how we know that all our moles have reacted. Okay. In a normal titration, candidates are usually advised to carry out more than one titration. All right? So here we have a table. Here we have a table. Normally we do a rough titration first, and then afterwards we do our titration until all the values are added. All the values look close enough. So here we have the initial burette reading, then the final burette reading, and then the volume used. So what we would do is to subtract the initial burette reading from the final to get our volume used. Now, the volume used should be close enough, at least 0.1. All right, so here we have 25.2, 24.8, that is far, 25.9, that is far, and here we do the titration again until we get somewhat of a close result. So these two are close, so we'll use those two. All right, so we'll use those two. So we need to carry out as many titration as possible to ensure that we have two close values that we can average. All right, that's how we'll know that our titration is working. So this is what the clamp stand looks like with a white background. The conical flask which Ruthann showed you, right? And with our phenolphthalein indicator, the sodium hydroxide was pink to start with, and then reacting it with HCl would cause it to go colorless after a while. So if you are asked to find the concentration of a solution of sulfuric acid by titrating 25 cm³ of the acid against a standard solution of sodium hydroxide solution, using phenolphthalein indicator, this is what it would look like. So here, you're seeing 0.1 mole per dm cube of sodium hydroxide. That is your standard. The 25 cm cube of sulfuric acid, that is your unknown. So after doing your titration, you will find the volume used, and the volume used can help you to determine the number of moles of sulfuric acid as well as the grams of sulfuric acid that was dissolved in the unknown. All right? So of course, you will set up the apparatus as shown, right, with our clamp stand. All right, and again, your table will look like this. Remember, we normally don't put the initial reading at the top. We put the final reading at the top because it will be easier. So the final reading is a bigger number that will be at the top, and our initial will go below it so that we can subtract the initial from the final to get our volume used, because we'll be using the volume used. And of course, the values that are close is 24.8 and 24.8. So we would do as much titration as possible to ensure that our volumes are close. You can't have numbers like our volume used like 17.8 and then another one at 25. That cannot work. You will have to do the titration over and over until they're just 0.1 difference. All right? And of course, we would use the two values, 24.8, and average them to get 24.8. So after getting the volume from doing the titration, what do? How can we use this to calculate our unknown? So the first thing we would do, if we're using sulfuric acid and sodium hydroxide, we would write our equation. And we would then balance the equation. This is important. The balancing is important. You have to know your charges to exchange your charges correctly, and then you balance the equation correctly. Because if you don't, then this will cause your calculations to be off. And we need to use the mole ratio in the equation to help us with our calculation. So here, it is saying that we need 1 mole of sodium hydroxide to react with 2 moles of sodium hydroxide. 1 mole of sulfuric acid to react with 2 moles of sodium hydroxide. All right? So here, which one was our standard again? Yes, that's sodium hydroxide. Because we had the concentration of sodium hydroxide, it was 0.1, right? And our sulfuric acid was our unknown. So here, we can see that it's a 1 to 2 mole ratio. If it's a 1 to 2 mole ratio, we need to find our sulfuric acid. We can use what we know to find what we don't know. All right? So here we have our concentration. Where did we get 24.8? Do you remember where we get 24.8? We got 24.8 because that is the volume of that is a volume from our titrant, right? So that is our volume that we got from the table, all right? And our 25 mils is what we pipette out. Using the pipettes, we pipette sulfuric acid 25 mils, and our sodium hydroxide, we got 24.8 after doing the titration. So how would we use this? We would divide by a half. So we say 1 times our volume times the concentration, and then we divide that by 2. All right? And times the volume. And our answer would give us our concentration of sulfuric acid that was used, right? So our sulfuric acid that was in the flask to begin with would have been 0.0496 mole per dm cube. So that is our concentration. So we can use a known to calculate our unknown. All right? So remember, when we're doing a titration, we should always have a known to calculate it with our unknown. All right? So let's do a quick check. So, questions. First one. After washing the pipette, it should be rinsed with. Write down your answers and we will come back. So select A if it's distilled water, B if it's the titrate, C the titrant, and D if it's tap water. Now, second question. After washing the titration flask, which is our conical flask, it should be rinsed with distilled water, the titrate, the titrant, or tap water. All right, here's a beautiful question. A titration flask contains 25 cm³ of sodium hydroxide and a few drops of phenolphthalein as indicator. It is titrated against hydrochloric acid contained in a burette. What color change would you observe when the endpoint is reached? What color change? So, Ruth Ann did something for you. Do you remember the color change that we should expect? Okay. All right. Here again, we have 25 cm³ samples of sodium hydroxide, and we titrate it with hydrochloric acid. So we have 0.225 mole per dm³ of hydrochloric acid. Now, can you look in this question and tell me what is our standard? Would it be the HCl or the sodium hydroxide? So, it would be the HCl because we have the concentration. All right. So here is a table that we would complete. So in the lab, when you're doing a titration, we would get our initial reading. So you read the burette before you start the titration. And at the end of the titration, you would record the volume. So that's how we can calculate our volume used, right? So we'd subtract the initial again, initial burette reading from the final burette reading, and we can fill out the table, and then after filling out the table, we can choose the best result, all right, the two that are closest. Then we can calculate the concentration of our sodium hydroxide. All right, now to answer our questions. I hope you selected the titrate. So after washing the pipette, it should be rinsed with the titrate. So you should clean the burette, you should clean the pipette with the solution that you're about to pull up in the pipette, all right, before you do your actual pipetting, all right? So after washing the titration flask with soap and water, it should be rinsed with distilled water before. All right, so after washing the burette, it should be rinsed with the titrant. So the burette and the pipette is done the same way. After washing it with distilled water or after washing it with tap water, you should rinse it with the solution that you're about to pour in, all right? When we're pouring in our solution into the burette, we would not use a filler. We would use the funnel to pour the solution into the burette. Now, and for this question, we have our sodium hydroxide. When we add our phenolphthalein indicator to our sodium hydroxide, of course, during the titration, that pink will slowly fade and it will give us a colorless solution. All right? So here's our table. And we have 4 values. We have 24.4, 24.5, 23.6, and 24.4. And of course, we will use the 2 closest values. And if we have 24.4 and 24.4, we would just add both of them and use them. All right? And we can use this to calculate the concentration of the unknown. And the unknown in this case is sodium hydroxide. Yes, and the concentration is 0.220 mole per dm³. All right, so remember, before we jump to calculate the concentration, we must always write the equation. The equation is important, writing the equation, balancing the equation, and remember to write your states. All right? Now, remember when we're doing volumetric analysis, we need to practice, 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 especially to do the pipettes when we're doing our titration. Also, we need to record our information. Record your information correctly and do your calculations. When you're doing a calculation, ensure that you write your equation properly. You record the information properly so that your calculations will make sense. All right? So, let's do another one to see if you understand. All right? You can do this one for homework, and then we will discuss this next time. So, that's a wrap for today's chemistry lesson.